Now let us do one very interesting problem based upon the two body problem. So according to the question, we have a circular disc of radius r which has uniform thickness. A circular hole of diameter equal to the radius of the disc is cut out from the edge of the disc. Find the center of mass of the remaining disc. So in this question, we assume this bigger disk of radius r and we put it in our coordinate system such that for this bigger undivided disk, the center of mass is at the origin. It's the geometrical center of the disk. Now, according to the question, a smaller disk whose radius is equal to the half of the radius of the bigger disk, or whose diameter is equal to the radius of the bigger disk, this is cut out. This portion is cut out from the main disk, right? And intuitively you can make out, earlier the center of mass was here, the center of mass will shift towards the left along the x-axis only because we placed it in such a way. Now how do we actually solve this problem? To solve this problem, we need to have the understanding or background of this two body problem. Let's recapitulate it. We have understood that if you have a two body system, so let's say this is our two body system and this is body 1 and this is body 2. Mass of body 1 is say m1 and its mass is m2 and the center of mass is somewhere here. And we have studied, we have derived that the coordinates of center of mass is equal to m1 x1 plus m2 x2 divided by the total mass of the system m1 plus m2. Now let's understand who's who in this. Now this xcm is the center of mass of the two body problem. This is x center of mass. This m1 is same this m1 mass of body 1. X1 is here, this distance. This distance is x1, the distance of mass m1 from center of the mass. This is x1. Similarly, m2 is this mass and x2 is the distance of second body from the center of mass. Now, if you consider the center of mass to be the origin, by using our conventions, distances on the left side can be taken as negative and distances on the right side can be taken as positive. So this is how we used to tackle a two body problem. Now let's see how do we fit in this two body problem here in this situation. Now in this situation, what we can do or imagine is that this complete disk can be imagined as a system comprising two bodies. Complete disk can be assumed to be a system comprising of two bodies. Body 1 is this bigger disk with a hole and second body is this smaller disk. So body 1, the disk without this smaller disk or with a hole, and second body with this smaller disk. Now if you combine the two bodies 1 and 2, you have this xcm as here, which corresponds to this, means which is our origin, and the center of mass of the second body will be placed at the coordinate r by 2. It's quite obvious because the diameter of this smaller circle is r, so this coordinate will be r by 2 and the coordinate or the center of mass, this body 1 will be somewhere here, we do not know it, so let's call it as x1. So if we now write our equation, which was center of mass equals m1 x1 plus m2 x2 divided by the total mass m1 plus m2. Now we'll tackle this equation. How do we solve it? Now here the variables which might bother us would be these masses. Now we need to take the clue from here. It is a circular disc having uniform thickness. So it means the mass of the disc is directly proportional to its area because its thickness is uniform. So mass m2 will be equal to, so let's write here, means with reference to physics, mass is equal to some constant. In technical physics we put that constant as sigma times area, A. This is area. Now m2 is our constant sigma times pi r by 2 square, right? And our mass m1 would be equal to sigma pi r square minus sigma pi r by 2 square, which means mass of this disk 1, means this disk without this smaller disk or with a hole, its mass will be the surface area of the total disk minus surface area of the smaller disk times sigma. So let's solve it mathematically. So sigma times pi can be taken as common. This is r square minus r square by 4, which comes out to be sigma pi, it is 3 by 4 r square. Now I think we can solve our equation. If you now check this formula and we substitute our values here. Now what is XCM? XCM is the center of mass of the whole system, which is obviously this origin, so it becomes 0. So our XCM comes out to be 0, equal to M1. What is our M1? M1 is, we have solved this as M1. So let's write this value. This is sigma pi 3 by 4 r square is our m1. And what is our x1? So this is our x1, right? So we do not know it, we actually have to find it. So we write x1 as x1 only so that it is found out. So this is our x1, the unknown. Then next is our m2 plus x2. What is m2? M2 is sigma pi r square by 4, right? And what is x2? X2 is now this, which is r by 2 times r by 2 and divided by m1 plus m2. I could have written the values of m1 and m2, but I am just avoiding it because it's in the denominator, and I know by mathematics it has to go on the other side and be multiplied with 0, and it will become 0. So no need to multiply it. Okay, now let's solve it. So this m1 m2 goes to the other side, gets multiplied by 0, vanishes. So one of these terms go to the other side of the 0 and becomes negative, one remains positive and other becomes negative. So let's write sigma pi 3 by 4 r square and r x1 equal to, now if this we consider to be going on the other side with the negative sign, sigma pi r square by 4 multiplied by r by 2. So it's almost done, we are home. So let's cancel out the common things from both sides. This sigma goes, the pi goes, this r square goes, right? And moreover this 4 also gets cancelled. Now our x1 is equal to, we are left with only 3 here, which goes on the other side in the denominator, minus r by 6. So this is our answer and we are done. The negative sign here indicates that this coordinate x1 is towards the left of our O. So this coordinate x1 has value r by 6.